Okay, so what we're gonna do in class today, since tomorrow is your very last test of the year, your test is broken into 4 sections. So there are 18 total questions. I'm gonna give you tomorrow, so that you don't feel like you are in a rush, I'm gonna give you both class periods tomorrow to work on this test. So when you have math, you're gonna get to work on your math test. And then when you have religion, you're gonna get to work on your math test. So some of you are not gonna need both full periods, I know that, that's fine. For those of you who don't need it, then you'll just kind of find something else to do, while the people who do need it take that time to finish. Because some of us have already recognized about ourselves as students that we mess up on things because we go too fast. So if you are given more time, which I don't want you to think that this is always what's gonna happen, but for the last test of the year, I want you to prove to me that all of my effort of standing in front of you for 170 days, you all have listened to things that I've said. And you all are gonna prove to me that for the last test of the year, that teacher goal that I have of everybody getting an A or a B is going to actually happen. And so if I give you 2 class periods, I believe we can make this thing work. So to even help you even more, today in class, we're gonna go through each section on the test, and we're gonna do 1 problem from each section of the test. Which means you're gonna get 4 answers to this test today. Now, if you are out there in the audience and you choose to not listen to me, and you choose to not take notes, and you choose to just kind of zone out and go to your happy place because you don't like math, then you're gonna miss it. And that's gonna be too bad for you. But for those of you who are dedicated and want this information, this is what today's class is gonna be about. If I let you use your notes for tomorrow's test, which I am, then you should be able to pull this stuff up tomorrow when you take the test and have access to 4 of the questions on the test before you even start the test. Okay? There's 18 total. So if we think about this, if I'm letting you use 2 class periods, 9 questions you should be able to finish during 1 period, and most of you will finish more than that. And then 9 in the other class. Well, each class is about 40 minutes, right? So that is about 4 minutes for every question. These problems should not take you 4 minutes to solve. So there should not be any difficulty from anybody finishing this thing. What? Quickly.
For the 4 questions that we're working on class, do we have to show the work on?
Yes. Yes, you do. Okay, and that was a question asked, in case you didn't hear what she said, she wants to know, since we're gonna be doing it here in class right now, do you still have to show the work on the test for those questions tomorrow? Yes, you do, okay? Because I'm not looking at your notes right now. Tomorrow's when I get to look at your stuff. So I need to know tomorrow that you actually found and saw what we did in class and you took it as good advice, okay? So whatever you wanna title your stuff for today, I would maybe call it like last test review.
I named it that.
Okay.
Also on the side.
All right, let's not take up any of my time. I didn't get through this with my other class. So we kind of have to like cut back on things we want to say and just be listeners for today, okay? So the first section, all right, of your test, the first part that you're gonna have to do is show me that you didn't forget how to divide fractions, all right? There is not any multiplying fractions on here. Multiplying fractions was a test that you all already took. The stuff on this test will only contain the things that we've been doing the last 2 weeks. And dividing fractions is one of those things that we've been focusing on. So problem number 1 on your test looks like this. It's 1/2 divided by 3. So if you were going to solve this thing, what would be the first thing we would have to do? So James, I'm going to choose you, and James, you're going to walk us through step by step what we would do if we were going to solve this thing. So James, what would be the first thing you would advise people to do?
You have to turn 3 into a fraction.
Thank you, James. So we would take that first fraction, keep it, but then we need to make that 3 turn into a fraction. And he knows that we do that by putting that 3 over a 1. Okay? All right. Now, James, what's the next step?
Keep, change, flip.
Good. And there are people in this classroom who are going to forget that. Don't you agree? So for those people over here to the side of your notes, I would put a star, and then I might even grab my yellow highlighter, and I might tell myself, don't forget to keep, change, flip. Because when you get so busy into working this stuff, that's going to be something that some of you are going to forget to do. This happened to some of you yesterday when we went over that math review day page. And you were searching for where you went wrong. We discovered you went wrong because you forgot to keep, change, flip. Okay? So now that we know we got to keep, change, flip, let's go ahead and do that. We're going to keep the first fraction the way it is. We're going to change division to multiplication. And we're going to flip this at the end to a 1 over a 3, right? So James, this is your problem. So now what would you tell people to do?
Simplify before you multiply.
Thanks, James. Right. So I'm going to just kind of draw my little lines here to get people to think that this is what you should do next. You should look diagonally and ask yourself, can you simplify? James, if I have a 1 and diagonal from that I have a 2, can I simplify that? No. What about the other direction? If I have a 1 and opposite of that I have a 3? No.
If you have a 1 and another number, you can't simplify.
Thanks for proving to me that you're listening. Good job, bud. Now, if there's nothing to simplify, now we just do what?
Multiply.
Straight across, right? So now we're just going to multiply whatever we have left. So at the top, Jane, 1 times 1 is?
1.
And the bottom?
6.
And if we would need to simplify again, we would do that now. But do we need to in this one? No. So the answer for the very first question on the test is 1/6.
I have a little trick to.
Now, no, we gotta save our talk. I'm sorry. Now, if anybody misses this one tomorrow, I have no words for you. Okay? I'm just going to probably jump out the window. Now, I don't want to just let that be the only example for this section. That is problem number 1 on the test. And that is the answer to problem number 1 on the test. And yes, you do have to show the work so that I can see that you did everything you needed to do to get that answer. Okay? But what if they all aren't going to look like that? And they don't. They're not all going to be a problem where you're just multiplying a fraction, dividing a fraction by a whole number. You're going to have problems where you're going to have to divide a fraction and a fraction. So we're going to just do an example of this one. This is not going to be one on the test. This is just going to be an example of something like one of the ones that you have on the test. Should you mirror my stuff in your notes right now?
Yes.
Because even though this isn't the exact problem, it's a problem that you could use to guide you through the ones that are on here. Okay? So here we go. Let's say that the problem was 8 12s divided by 6 20s. Okay? That's not a problem on the test, but there is one on it that's like that. So what would we do in this situation? Olivia, you're going to take this problem, okay? Here we go.
Since there are no whole numbers, you don't make a fraction, so you do not step number 2, just keep changing it.
Nice. I love it. She could be the teacher. There's nothing we have to turn into a fraction. They're already fractions, so now it's time to keep, change, flip. So Olivia, show me what that would be.
You keep the 8 over 12. You would change the division side to the multiplication side. And you would change 6 over 20 to 20 over 6.
Thanks, Olivia. Okay. Now, Olivia, what would be the next thing to do?
Simplify.
Good. Do we have options to simplify here?
Yes.
We absolutely do. One of the things for those of you who are like, I'm never really sure if I should simplify, the thing that you have to start paying attention to is if all of the numbers are even, which in this example they all are, 8's even, 12's even, 20's even, 6 is even, then what number can always simplify even numbers, everybody? 2. Good. But we're gonna see here in a minute that 2's not the one that you need to use for all of them. But you could. So I want you to solve this. Go. Solve this problem. Get your final answer. Hang on. If you got it, you gotta just relax and hang on. Now I'm gonna tell you, I'm not giving you a long time. I'm giving you 1 minute starting now to get an answer. Some of you are already there. If you want to check with your neighbors, see if they got what you got. It's always comforting to see somebody else got what you got. You got a question? Yeah, go ahead. I'm just gonna, Rory just said, can we grab our snacks? And my answer is yes, but I'm gonna keep moving, so don't lose track of me while you're getting your snack out. Okay? All right, you got 15 seconds left to get this answer. Time. All right, so this was Olivia's problem. We're gonna go back to Olivia, and I'm gonna say, Olivia, what'd you get?
I got 2 and 2 9.
She got 2 and 2 9, 2 and 3. Wow, Olivia, a lot of people agree with you. Somebody get something different? What'd you get? 1 and 2 over 3. Okay. Anybody agree with Max on that one? Ooh, you don't have to take your Max. That's okay. That's all right. Believe in yourself. Don't necessarily think the crowd's right. Anybody else get something different? What'd you get? 1 and 1/3. Anybody else get that? Yikes. It's okay. All right. Well, let's work this thing and see what we get. So if we simplify, which we know we can, Olivia, 8 and 6, let's start that direction. What can they both be simplified using? They have a 2. So I'm going to slice each of these by a 2, and what's my 8 going to become?
A 4.
What's my 6 going to become?
A 3.
Good. For those of you who are like not sure what the answer is, and nobody knows what the answer is but me, so what you guys need to do is check your steps. If at any point in time something that I do here on this screen does not match what you did, you need to fix it in your notes. Otherwise, tomorrow, you're going to be using wrong information to help you solve a problem. And then what are you probably going to get on the test? Wrong answer. So make sure that you do what I'm doing so that your stuff is the right stuff in this notebook. Let's go the other direction, Olivia. We've got a 20 and a 12. We could use a 2, and some of you probably did. Who did? All right, that's okay if you did. But I'm going to say, if you used a 2, you had to do something at the end. People that didn't use a 2 didn't have to do that at the end. So Olivia, what did you use?
I used 4.
She used a 4. Slice each of these by a 4, Olivia. This becomes a
3.
This becomes a
5.
Good. So far, this is what your work should look like. You found your error. Good. So for those of you who made errors, have you found your error?
I just fixed it.
Okay.
I think I copied wrong. I put it 12.
But those, I don't need to know it. You need to know it. You need to stop doing it. End of story. Now we're ready to just multiply straight across, right? So the stuff left over at the top gives us what? 20 over 9. Love it. The 20 over 9 is improper, right? So now we have to simplify this. I know most of you already know how to do this, but just in case you need to see it, you need to flip this thing on its side. The 20 goes in the box, the 9 goes on the outside. 9 goes into 20. How many times?
2 times.
And then when we subtract, we are left with 2. And my 2 goes on top and my 9 goes underneath. There's your final answer. Those of you who used your 2, you ended with 2 and 4 18s. And then you had to then cut 4 18s into 2 9s, right? But you should have landed at 2 and 2 9s. So once again, who got it? Good Good job. If you didn't, remember, whatever error you made, make a note on that paper to not make that error again. So like if your error was a copying wrong error, you need to take a highlighter and remind yourself, don't copy things wrong. That's like your warning sign. If your issue was a simplifying issue, which I don't know, what was your issue?
I did.
Yours was yours what? It was a division issue, so that's probably a simplifying thing. So you need to give yourself a note. Don't simplify incorrectly. Be careful when you simplify. What?
Oh, my gosh, what I answered was, I didn't simplify at the end. I used the two.
Oh, and then you slice those?
And then I sliced
Good, that's good. All right, hurry, yes.
I'm gonna put my water bottle.
Be fast. You're gonna miss something though. I'm moving on to the next answer on the test.
What is it? What's it on?
Huh?
What's it on?
I can't, you just go do what you need to do. Okay? All right, are we ready? So this is section 1. There are 5 of these in section 1. So I have given you 1 of them, which means you only have to produce the answer for 4 more. Can you do it?
Yeah.
Excellent. Let's move into the next section, okay? The next section has a new title. That section is titled, What is the reciprocal? Okay, this is section 2 on your test. What is the reciprocal? Okay? Mason James is locked out. Would you go right back?
How the heck did he go that fast?
What?
He's running.
You was just getting one.
Yeah,
One
we
back.
missed
You made it.
It's on the reciprocal.
Now, you guys are taking time. Remember the more you take my time, you don't get stuff. That's how it works. So what is the reciprocal? Well, for those of you who have forgotten what reciprocal means, Brady, what does reciprocal mean? Huh? Flip the fraction. If you need, Macy, okay? If you need to give yourself that little note, then take your little highlighter and remind yourself that reciprocal means flip the fraction, okay? These are now becoming important algebra-like words that you need to get into your math brain. You will hear reciprocal a lot in your future. So as you grow, words become part of your growing. And this is a word that you need to not forget, okay? So on your test, it's question number 6, okay? So question number 6 on your test looks like this, 18 over 3. And then on that blank line, you need to tell me what the reciprocal is. So if reciprocal means to flip the fraction, then Brady, you take this. What is it, bud?
3 over 8.
It becomes 3 over 18. That's it.
How many questions are in
Okay, that's it. So do you have to simplify that? No. You just flip it. That's all I want you to do. Okay? This section has 3. Not a lot. Okay? But they don't all look just like that. So now I'm going to give you an example of what another one might look like. Okay? Because sometimes they're not just fractions. Sometimes you have to find the reciprocal of a mixed number. So let's say that it is that. And you have to find the reciprocal of 5 and 3/6. So just by a show of hands, who thinks they would know the answer to this? Colin, what do you think?
I was thinking maybe you could do the backwards C and then flip it.
You're a smart man, Colin. He realizes that this thing is not just flip 3/6, because that wouldn't make sense. But before he can flip it, he's got to turn this mixed number into a fraction first. So the first thing he needs to do, as he said, is that backwards C thing. So to make that backwards C, you've got to multiply here and then add up there. So when you do that, Colin, what does this become?
33/6.
It does, it becomes 33/6, but we still haven't made it into our answer yet. All we've done at this point is turn that mixed number into a fraction. Now, we gotta do the reciprocal.
Which is 6/33.
So the answer I wanna see is 6/33, okay? So, that exact problem is not on your test, but there is one like it. So you should have that example on this paper so that tomorrow, when you see the one on the test that does look like this, and you're like, oh man, how did I do that? Oh wait, let me look at the notes. And you see this and you're like, oh now I get it. So you don't have to raise your hand and go, Miss Mom, I don't even know how to do this. Because that's what we're gonna jump out the window, okay? All right, so that's section 2. Section 3. Section 3, here we go. So section 2 shouldn't take you very long, I would think. Section 3 is multiply decimals. You're taking up my time. Okay, yeah, what? That's right. This thing's getting in my way. Okay, all right. So, the section on multiplying decimals, the problem I'm going to give you is problem number 9. Okay, so this one's problem number 9. Don't get lost. Okay, stay with me. All right, and it looks like this. 0.87 times 10. Okay. So you've got to think, how did you learn to multiply decimals? So Tessa, you take this one. All right, so Tessa, what are people going to have to do first?
So first you would remove the decimal, so it would just be a whole number,
Okay,
and you would do 87 times 10.
good. 87 times 10. Okay. Now there's a lot of you in here who are going to say, I can multiply 87 times 10 in my head. Do I have to show all the steps? And my answer to you is no. If you're one of those people that thinks that you have kind of advanced to doing stuff in your head, I'm cool with that. But just know that when you do stuff in your head and your head makes a mistake, I can't crawl into your head and see what you did wrong. So be careful on doing things in your head is all I tell you. But yes, this is absolutely a problem that you can do in your head. But if not, let's just show what it would look like if we did the work. So we would have to multiply our 0 by everything at the top, right, Tessa? So 0 times 7 is? 0 times 8 is? Okay. Now we gotta move on to our 1. But I have to put my 0 placeholder before I do, right? 1 times 7 is? 1 times 8 is? Okay. Then I'm gonna add this stuff together. So when I did 87 times 10, whether I did it in my head or I worked it out, you should have gotten 870. Now the job is figure out where the decimal goes. So Tessa, what's that job?
You would have to count how many numbers there are after the decimal.
Good. So in the problem, how many do you see?
2.
There's 2 right here in this number. Is there any in that one? No. So in total, there's 2. So Tessa, in my answer, where's it gonna go?
After the 8.
It's gonna go after the 8 right there. So you could leave your answer as 8.70. Emily, you have gone into La La Land. I can tell. You're gonna miss this. Come on, stay with me. 8.70 is what we got. But if you want to kind of put this into its final form, Tessa, what would it be?
8.7.
There you go.
Or couldn't you do 9? Or
Well, no, don't work with rounding it, okay? You can kind of stick with that with division, okay? So you can dump that 0 at the end. You don't need it. Once you know where the decimal goes, then if there's zeros left over that are in decimal land, you can get rid of them, okay? But either one of those answers, I would be completely okay, okay? That's question 9 on your test. All right, so let's try an example. So, because they aren't all multiplying a decimal times a whole number. Some of them are actually multiplying a decimal times a decimal. So let's do 4.3 times 6.25. So if you were going to solve this thing, now this is not something you can do in your head. So we're gonna remove the decimals like Tessa told us a minute ago, and we're just gonna multiply the numbers that we see. What's the biggest number that we see, everybody?
625.
625, and we're gonna multiply that by? So please make sure that you line up everything correctly, because if you do not, you may end up with not the right answer. What?
I'm trying to.
Huh? What?
Oh, there.
What'd you say?
I was gonna say.
Oh, yeah, you can. Here. I'm gonna give you all, this one, these kind of problems are the ones that on your test are gonna probably take up more of your time. Because these are the areas that you gotta go slow. Because there's places for you to focus on. What we do? All right, so Sophia's gonna walk us through this one. Okay, whether she's finished or not, we're getting close on our time, we're running out, and I don't wanna miss out on that last problem. So Sophia, let's make sure we don't make any multiplication errors. Everybody's checking their steps. Make sure that your partial products match our partial products. Okay, here we go. So Sophia, multiply for me.
5 times 3 equals 15.
Okay.
5 down, 1 above 15.
Good.
So, then 3 times 2 equals 6, and add 1 equals 7.
Good.
3 times 6 equals 18.
Okay, so far, that's your first set of partial products. So check to make sure that the first thing you have is 1875. All right, now move on, Sophia.
Add your placeholders to 0.
Good.
And then 4 times 5 equals 20. So instead of 0, I'm going to 2 over 2.
Okay.
And then 4 times 2 equals 8. Add 2 equals 10. So then you make another 0.
That's plus zeros.
And then you do 4 times 6 equals 24. And add 1 equals 5.
Excellent. That's your second set of partial products. You with me still? Okay. All right, last step.
So then 5 equals 3 equals 5.
Well, now we gotta add. Good. Okay.
5 plus 3 equals 5. 7 plus 0 equals 7. 8 plus 0 equals 8. 5 plus 1 equals 6. And 2 plus 0 equals 1.
Good. Good. Okay. So make sure that your digits are all 2, 6, 8, 7, 5. Now it's time to put this decimal where it belongs. So we gotta go back up to the problem, which is sort of hiding right now. So here's the problem. How many total digits are behind decimals? 3. So now we're gonna come down here and put 3 behind. So where's it gonna go, Sophia?
After the 6.
Nice work, girl. That's your final answer, okay? So there is some problems in this section where you have to do stuff like that. So now you have an example of that one. There are 5 in this section. We did 1 together, so it only leaves you 4 left to do, okay? All right, we've made it to the final section of the test. The final section, and you know what it is, dividing decimals.
Dividing decimals.
Okay. Shh, I'm down to 5 minutes before you have to be upstairs in the library. Okay, all right. So this sample problem is number 14 on your test. It's the last freebie that you get.
Yep.
Okay. And this problem looks like 5.6. It is number 14. So 5.6 divided by 8. Okay? So the problems are written out going long ways, and I'm challenging you to know what number goes in the box and what one goes outside. So Henry's going to take this one. All right, so Henry, what number goes in the box? So he knows that he's going to set this problem up by putting 5.6 in the box and 8 on the outside. Okay? Now, what is the first step when we divide decimals, Henry? Nice work, dude. So there are going to be people in here that are going to forget that because you forgot it on that math review day page. So now I want you to get that little highlighter again, and you're gonna highlight, don't forget to move that decimal. Okay? Don't forget, if you have it highlighted, it should stand out to you as like a bold, like green, what you do. Okay? All right, so please don't take up my time. Henry's gonna look at this problem. All right, Henry, so do we have to move a decimal here? We do not, because there is no decimal on the outside, so I'm just gonna start with like step 3, which says to do what, bud? Okay, I'm gonna take a break and I'm gonna just put my pen down and say I'm done with class, because some of you are talking while I'm talking, or the person I have chosen to talk is talking. I'm not doing this for me, I'm doing it for you. So if you don't care, I'm gonna say I'm done. But you should care. So stop talking when it's not your turn. Henry, going back to you.
You moved the decimal up on top.
Good. You gotta line that decimal up on the roof where it needs to be, and you gotta do that first. Those of you that try to do it at the end, that's when your decimal was all out of whack on that math review day page. Don't try to do it your way. Don't be a hard head and do it your way. Do it the way that you get the right answer, okay? All right, now, will 8 fit into 5, Henry? Will 8 fit into 56? How many times? Where's the 7 gonna go? It goes above the last digit we used. We had to use the 5 and the 6, so the 7's gonna go directly above that. 8 times 7 is, when I subtract, I'm left with, do I have to do anything else? No, this problem is done. So your answer is 0.7, okay? That's the answer to question number 14 on your test. But I'm gonna end you with one more example, because this example does not include having a decimal on the outside. So the last question that we're gonna do is gonna be one that I'm gonna make up, and it's gonna be one that's gonna look like some of the ones on this paper, okay? So we are gonna do this one. Let's do 4.36 divided by 0.92. Okay? So to set this problem up, you've got to put the first number listed in the box, right? So 4.36 is what's going to go in the box, and outside the box is 0.92. Now, some of you are going to say to yourself, can I skip that step and just start moving the decimal? I'm going to suggest to you, no, you're just now learning how to do this. You're not ready to skip steps until you become a pro at dividing decimals. And none of you are pros yet. So you need to write it out so that you can see where everything is supposed to be first. Now, move that decimal. So how many places we got to move this decimal to get it where it needs to go? 2. So in the box, we have to do the same, right? So now I'm going to rewrite it, showing myself where everything needs to be. So now on the outside, I just have a 92. Do I need that 0 really? No, it's going to get in my way, so I'm going to just get rid of it. On the inside, I have a 436 decimal. That's what things should look like now. Okay? Now, step 3, because that was step 1, was to move the decimal. Step 2 was to move the decimal inside the box. Step 3 is to line it up on the roof. And now, step 4 gets to start working. Okay?
I don't like.
So 92 is a number that I'm trying to fit into 43. Will that work? No. Remember, if there's 2 digits on the outside, I start trying to divide with 2 digits on the inside. But this won't work. There's not enough. So now I have to use 436. So I'm trying to figure out how many 92s will fit into 436. So I'm not sure. Did some of you think you got to it? Tessa, what do you think?
4.
Tessa thinks 4. So I'm going to come over here to the side and I'm going to kind of challenge her and I'm going to say, okay, what's 92 times 4? 92 times 4 is 368. That is really close to 436. Does anybody think that we could get 5 of them? She thinks 5, so let's just see, what's 92 times 5? That's 460. But I love that we try it. It's always good to try, just to make sure. Because sometimes you don't end up going far enough, and then you end up like getting things wrong. So we know Tessa's right. 4 of them will fit. So Tessa, where's that 4 gonna go? It goes above the last digit we used. We just used the 6, so the 4 is gonna sit on top of it. 92 times 4 we just discovered is 368. Okay? Now I gotta make sure I don't make a subtraction error here. So here I go. 6 minus 8, I can't do that. More on the floor, I gotta go next door. 3 turns into a 2, 6 turns into a 16. 16 minus 8 is? Now let's move to the 10 section. 2 minus 6, I can't do it again, I got more on the floor. So now I'm gonna have to borrow from my 4. 2 now becomes a 12. Things are getting a little messy here. 12 minus 6 is 6. 3 minus 3 is?
0.
Nothing, okay? All right, so I got stuff left over and I've used every digit in the box. So what do you suggest that I do? I'm gonna have to add a 0. I'm gonna add a 0 right here behind my decimal, and I'm gonna pull that thing down. And now I've got 680.
I ran out of
So how many 92s will fit into 680? Well, 5 of them, it gives us 460. Anybody figure this out? How many? Brody. He says 7. I don't know what 92 times 7 is.
It's 644.
It is 644. We're not gonna get any closer. Would you all agree? So where's your 7 go, Brody?
The 7 would go above the 8 for 0.
It goes above that 0 that I just used. And then I'm gonna bring down my 644. When I subtract, I need more space. Come on, okay? This turns into a 7. I've got 36 left over. What do you suggest I do? Add a 0, drag it down. 92 will fit into 360 how many times? Well, I had my work. Notice how I didn't erase my work. That was smart for me to do because I'm needing this stuff now. Will 4 of them fit? Too much. So we know it's gotta be how many? 3. Let's put our 3 up there. What's 92 times 3, you guys? 276. Man, all right, let's bring it. Okay, that's good. Okay, let's bring it down. 276. I'm left with, and I'm doing some quick math here because we're running out of time, 84. What do you suggest I do now? Add another 0. Pull it down. I gotta work till I get 3 digits behind my decimal level. How many will fit? You think 8? All right, let's see. What's 92 times 8? That's 736. I don't think we're gonna get any closer, but let's try 9 just to make sure. That's 8. Actually, that's 828. 9 of them is closer. Okay, so we're gonna put 9 up there on our roof. Bring that down. Finish up our problem. And believe it or not, we still have things left over. But at this point, we're gonna hit the stop button. Okay. So you have 4.739.
You got the 4.73913.
Could you, once you get 3 numbers behind the decimal, 4.739, if you left it as that, I would say you're a rock star.
But once you get to that, it gets to the point where it gets to 280 minus 276 and you get 4.
And then it starts repeating.
And then even if you brought a 0 down, you still wouldn't be able to put 92 into it.
Gotcha. Okay.
Why not?
Now, if you wanted, okay, before we lose track, so this right here with all of that stuff, this would be what, if you got that answer, I would say you're good. How many of you got that? Excellent. Now, how many of you would know how to round this? What would it look like as a rounded answer? Brennan?
So 739, you go from the right from the 3, which is a 9, and it's 5 or more, so you go 4. So
Good.
4.740.
Excellent. 4.74. And you, that 0 at the end, now you can dump it and just say 4.74. Okay? All right. You guys are ready. If you all nailed that thing, nothing on the test. Let's get upstairs. Hang on, please. Hang on, please.
You check it.